come to another workout problem. This one is a good one here. It says, what is the acceleration of a car in terms of g, which is going at a speed of 40 miles per hour in a circle of 50 feet radius, okay? So once we get the acceleration, then we're gonna relate it to the acceleration of gravity. And that's kind of a benchmark for us because the acceleration of gravity is a big acceleration, very fast acceleration. So if you're compared to that, if you're larger than that, then you're really accelerating too fast, right? So you're going here in a turn like that. Your speed is 40 miles per hour, and your radius is given 50 feet. So in this case, since the radius is given in British units of feet, we want to convert our speed to feet per second. If this radius was given to us in meters, then we would change the speed to meters per second. So meters per second and meters would match. But here, since this is feet, I want to convert this to feet per second. So I say 40 miles per hour, okay? Then we can make 1 hour is 3,600 seconds, and then 1 mile is 5,280 feet, okay? So then I will convert that to feet per second. 40 divided by 3600 times 5280. So it's going to be 58.666, repeating sixes, feet per second. So 40 miles an hour is that, feet per second. Then I'm going to use the equation. Acceleration is velocity squared over radius. And then velocity is basically, the speed is the magnitude of the velocity. So that's what I'm going to use here. So I'm going to say 58.666 repeating sixes squared over 50. So I'm going to square this number that I just got, the 58.666 squared. Okay. Then I'm going to divide that by 50. Okay. I'm going to get 68. 68.83555, and repeating fives. Then what are the units of that? Well, this was feet per second, and then this was feet. So when you square feet per second, what do you get? When you square feet per second squared divided by feet, right? What happens is this ends up becoming a feet squared per second squared divided by feet, and this feet will cancel one of those feet, so you get foot per second squared. That's the units of acceleration in the British unit system, feet per second squared. So that's the units there. So that's actually a pretty fast acceleration, very fast acceleration. Okay, how many G's is that? Well, the value of G in the British system is 32 feet per second squared. Okay, so this is almost like greater than 2 G's, right? So divide this by the acceleration divided by G. So if I want to know how many G's this is, I take the speed, the acceleration, divide by 32. This is 2.15 G's. This is kind of too much acceleration, right? This is the kind of acceleration that you want your astronaut trainees to eventually experience. You want to put them through training. They should be able to withstand 8 G's, 9 G's, 10 G's of acceleration, okay? A typical person might be able to withstand 2G, 3G, but the astronauts, they should be able to train for 8, 9, 10 G's, you see? So this is a very fast acceleration. Your 2 G's of acceleration, this is too fast for this radius. What would happen if I double the speed, if I triple the speed, if I half the speed, you see? What if the car is going 20 miles per hour? Half the speed. What's going to be the acceleration? Do we have to go through a whole calculation again? The answer is no. We already know 40 miles per hour is 2.15 G's. What's going to happen if I half the speed? 2.15 G. Well, what's the speed now? If I'm halving the speed, the acceleration is proportional to the speed squared, right? So the new ratio of A to G is going to be what? Okay. A over G, this is going to be new, my new ratio. It's going to be my old ratio, 2.15 times 1/2 squared. You see, so since acceleration is velocity squared divided by radius, right? If I make the velocity half, then I have to square that, half squared. So this is going to be 2.15 over 4. So if you divide, so going 20 miles an hour over a 50-foot, around a 50-foot radius, that's more handleable. That's only half a g, right? You're experiencing half of the acceleration of gravity, okay? We could also change the radius and make it a gentler radius, right? We talked about that earlier. We could make it a gentler radius. What if you keep the speed at 40 miles an hour, doubling the radius? What will happen? You see? So now the radius is bigger radius. So keep the speed at 40 miles per hour, but the radius is now 100 feet. What will the acceleration be? Again, we don't have to go through the calculation all over again. A over G, 2.15. What have I done? I've kept the speed the same, but only doubled the radius. The equation for acceleration is what? V squared over R. So if I'm keeping the speed the same, but only doubling the radius, the new ratio is going to be 1/2, right? So because this is now twice what the original radius was. So it's in the denominator, right? So you're going to have 2 here. Well, this time it's going to be 1.15. This is also better than 2 g's. This is only 1 g of acceleration, you see? Because it's a gentler turn, it's not as sharp. So now you see how you can calculate the acceleration, convert from mile per hour to feet per second, then square that, divide by radius. But now if you're given a new speed, you don't have to do the whole calculation all over again. You can just do it in terms of ratios, okay? Thank you very much.